So, the title is the panel on the standardization of C++. So I have quickly please introduce ourselves. I'm Alisdair Meredith. I've been with the C++ Standards Committee for about 9 years now. I signed up just after the 2003 standard got done, just at the start of the C++ 11 standard, which seems to be a fun time to get onto the committee. But I don't have much of a history of how the standard came to be, which is probably where I would like to start this panel, just so I can learn as much as you. So, going from my right and down.
I'm Matt Austern. My first standards meeting was the Santa Cruz meeting. I think it was in '95. Alistair did not mention that he's the current head of the library working group on the standards committee. I used to have that fun job before him.
Hi, I'm Winkel, and my first C++ standards meeting was in London in '97. And I had a period of 5 years where I wasn't involved, but all the time that I was on the committee, I was the head of the Dutch delegation.
Hi, I'm known as Crowl. It turns out my first meeting was also the '97 London meeting, so we're all in the same class here.
I'm John Caves. My first meeting was actually the Valley Forge meeting, which I think was '94. But then I dropped out for a while, and I came back then for the Tokyo meeting, which was in '99.
Okay, so I think I'd like to start with, why is C++ standardization such a good thing? Not all languages have an ISO standard. Why did we think it was a good idea to go through the ISO panel first? And I'll straight over to Matt.
Well, this gets to a issue that was raised this morning. The reason that we have a standard is that we can have multiple independent implementations. If a language does not have a standard, then effectively it is defined by the implementation, and the important word in that is the. If you're going to have multiple compilers and have any hope that your program is going to work the same way on them, then you have to have some kind of a specification that all of the vendors are working towards.
I'm a bit at a loss. I think that it's important to have a standard because you want people to know what to aim for. And also for teaching, it is good to have an authoritative document that you can refer to. I mean, if you wanted to teach people, say, Photoshop, which is not standardized, then you'll have to grab your information as an educator. You have to grab your information from here and there. Whereas for C++, there is this nice 1,376 pages worth of standard that you can write a real decent courseware material from. And actually, that's the way I started being involved in C++, because I was writing courseware and I needed access to the standard. So I think it's good for educating people.
That's on down the line.
So there's another reason that a standards process is good, is that a standards process is actually a bit more difficult. So if you want to change the language, you have to go to the committee and be convincing. The committee will make you do the work and will evaluate the work. If it's sort of a one company little language, then it's much easier to change the language, but it's also much easier to make a mistake with it. So the standards process helps on quality control.
Yeah, I think I'll agree with Lawrence on that. I mean, it really helps to get a group of people in a room to thrash out what exactly this language means and what the impact of the change you're proposing will actually have in all corners of the language. But I also think, at another level, having a standard body and having the meeting acts as a sort of catalyst. I mean, you get all these people who sort of love C++, spend all their days thinking about C++ together for the week. And we do sort of not only standardize the language, but we also evolve it as well.
Yeah, keep an eye open just in case anyone wants to raise their hand and ask questions at any point through the panel. Otherwise, I'll keep going with my own questions until we all get bored. Gabby.
Are you paid to do the work?
Okay. Question. Are we paid for our involvement with the Standards Committee? Personally, my employer sends me to the committee now, which is I'm remarkably grateful for. When I first signed up 9 years ago, I turned up out of the goodness of my heart. It was a hobby, something I was very interested in, and my motivation for turning up was not so much I was paid to turn up, but I got such an education from meeting these people and talking about C++ at a level that of discourse you don't get many other places. I couldn't go to a conference and learn C++ at this level, so my first few meetings, I was cheating. I was going there for an education. Unfortunately for these guys, I stuck around, so.
And my employer also pays for me to attend meetings. It is not my full-time job. You've perhaps heard of the notion of 20% time at Google. This is essentially my 20% project. It's something that I do part-time. And I believe that that's typical, that most people who go to represent their companies are paid by their companies to do that. But there are very, very few people whose full-time job is the standardization of C++. Perhaps not.
I've never heard of any.
I have, except for 2 times when I paid for it myself, I've been paid by my employer to go. And I want to add to what Alisdair said. If you go to a C++ standards meeting, you learn an enormous amount of new stuff. And that is not leaching, because if everyone just gives 2%, you only have to give a little bit. If everyone just gives a little bit, everyone can learn an enormous amount of stuff. So, and many eyes make it better for getting better quality. More eyes looking at the document will find more bugs in the document.
So I'm in the exact same position as Matt. So.
Me as well, that my employer pays for us to go. So. Bjarne?
Could you comment on the negative effects of the sign library?
I sit on the core committee. These are the group who actually deal with the fine minutiae of the language. One person made the comment years ago, like when she came into the core meeting room, it was like entering a sort of Quaker church room, sitting around, really quietly, just staring at this text in front of us. We can literally spend hours going over one paragraph trying to decipher exactly what it means, and have we said it in just the right way so anybody would know exactly what we mean. So that takes time, and sometimes I think we spend more time maybe than we should. I mean, I know there's some people, I believe someone in this room wish we could do things a bit faster, but it's a complicated language, and I think we need to have the eyes on it and the review of the text to make sure it really does. Because I think one of the biggest problems of bringing new additions to the language to the committee is people tend to think of the languages, the new features in isolation. And the problems always come when you combine those features with the other features in the language, maybe features you haven't even considered as part of your proposal. So, yeah, that's just really the committee. Different people have different opinions, and different people some people feel we should do things very carefully. But over a whole, I think that at the end we do come out with a good standard. Maybe not as quickly as we could, but we get there.
So one of the things you have to deal with when you're doing the committee evaluation is that no two people come to the language with the same understanding of the language or the same needs out of the language. And so if somebody shows up with a proposal, that proposal is usually tuned, usually incidentally, to both their understanding of the language and to their need. And then somebody else comes along and says, well, I don't need that. You're doing nothing for me. And so, but I need this other thing, which is sort of similar. And so you end up sitting in a room and hashing things out. And you end up with a feature that can do both things. But for any one purpose, it's more complicated than necessary. And so that's where a lot of the complexity of C++ comes from, is that it's trying to handle an awful lot of different needs without getting too many excessive number of mechanisms.
I think design by committee is it's one of the dangers of the committee. It does tend to slow our process down. If you're wondering why it took 10 years for us to get from the last standard, and was it 10 years from C to C++ as a standard as well? I believe the C++ standardization kicked off shortly after C was done.
It was more like 9 years.
So,
like 15.
So the downside is it's taking us a long time to evolve the language, but on the upside you get a very stable language during that time. You know in theory what you can rely on. I say in theory because it took us a fair while before we actually started having standard conforming compilers after the 1998 standard came out, to the point you could rely on all your compilers being standard. To an extent, even that's only just being delivered now as a C++ 11 standard. It's just come out and moved our goalposts again. The good news is, from what I'm seeing of the C++ 11 implementations, we should be looking at hopefully a shorter way for these to start shipping full C++ 11 standards. But even now, the first one isn't out yet. GCC and Clang are fairly close. I see Microsoft decided to make advances again, and we'll hear from other power vendors soon enough, I hope. Yeah, I think I'll pass on.
Design by committee has the danger of people making compromises and not getting the best. Another point is that what Lauren said, people may want things and make a proposal for that. We are not always standardizing existing practice, which may cause big failures, such as the export templates thing that was implemented by one party and then abandoned in the next standard because no one else would implement it, and that would not happen if you don't standardize in a committee, but you standardize existing practice. The not having a moving target thing is good.
So I think that there are a couple of answers to Bjarne's question, a couple of different ways we could interpret it. One is specific ways in which the standards process has led to results that we didn't all like. JC gave the example of export, where that wasn't just designed by committee, but invention by committee. We had a problem, everybody on the committee knew that there was a problem, we wanted to find a solution, so we all sat down and talked. We came up with something that we hoped was a solution, standardized it. It turned out that it was not the solution that we had hoped for. That's one of the characteristic dangers of design by committee. Hans also mentioned an earlier example earlier today that where design by committee can fail. Again, we had a problem that we knew we wanted a solution for, thread cancellation. We had essentially two proposals on the table for solution, for solving it. Neither of them got a consensus, and as a result, nothing happened. And then yet another characteristic danger of design by committee is a compromise where one group wants a feature that does this, another group wants a feature that does that, so everybody decides, well, can't we all get along? Let's compromise, let's do both. And actually, that's worse than the first failure. I'm glad that didn't happen with thread cancellation. It did happen with our string class, if you look at the API. But a different answer to Bjarne's question is, what's the danger of design by committee? And the answer is, you should ask a different question. Compared to what? You can instead have a dictator with good taste. That has some real advantages, actually, if you choose the right dictator. Or you could have a actual development organization that is paid to write a standards document, that's paid to write a specification. That has some real advantages. You can have an actual roadmap. The committee cannot have a roadmap. We've been mentioning proposals here. We haven't been very specific about what we mean by that, but I hope there hasn't been any real confusion about it. The bottom line is that the committee is essentially reactive to what individual members or organizations propose. A full-time development organization that can set roadmaps wouldn't be. However, it should also be obvious that both a dictator and a full-time development organization have disadvantages of their own. We get some real power by being a international standard that's designed by consensus, and we'd be giving a lot if we'd be giving up a lot if we try to do this process some other way.
Sorry, just one last other classic typical thing you get from a committee is that the large issues tend to be technical, and a small number of people in the room know those, so you're not getting the full benefit of the committee. You're getting the distilled wisdom of the 2 or 3 people who are arguing that point and everyone picking their favourite. As soon as it comes to something like picking a keyword, everyone has an opinion.
Big.
So I've got, that's right, can I see your name from here?
Yeah, I'm Jacob from Texas. So I have 2 questions. One is, what's the audience, or who are your audience? Because I don't know how many end users of C++ actually read the standard. I learned from textbook and then from the web and all that stuff. So,
I mean, who are the audience of the standard?
what I've tried to take the standard once. It's just, maybe once or twice. I decided not to just put that on. So the second question is, I realize that most of you here are probably technical people from Google and all of that. So how much of influence do you have from government, United Nations, people who are not technical people? I want to think there's a form of politics in getting this done.
Okay, so I have 2 questions there. Who is the intended audience of the standard document, I believe? And what is our contribution from non-technical C++ people in the standards committee? Well, I'll take the second question first. In terms of the working group that we're all members of, which is working group, its full name is JTC1 IEC, can't remember.
ISO.
I think Jan's got the name yet.
So it's ICE ISO JTC1 SC22 WG21. So the IEC and ISO, they have formed a joint technical committee of which there are several. For example, I believe JTC4 has to do with energy efficiency, and JTC1 is about information technology.
Yeah.
Then within JTC1 there are several so-called subcommittees. For example, there is a subcommittee about multimedia formats, there is a subcommittee about programming languages, which is SC22, and then there are working groups under SC22, such as working group 14 for the C language, and working group 21 for C++. And then within that, we have subgroups for library and core, but they don't have numbers.
Not yet.
And your question about the audience, well, obviously the compiler writers are part of the audience, the library writers, and the people writing the textbooks that you read to learn C++.
There's a standard line that a lot of people on the committee say to each other. The standard is not a tutorial. It is known that the standard is very hard to read, and that it is widely believed that that's okay. That the intended audience is technical people who are willing to work very hard to read the document and deduce guarantees from it. The idea is that it's not necessary to spell out the full consequences of everything in there. Now, I don't know if that is an entirely correct attitude. I think maybe the people who write the standard are a little bit too willing to let themselves off the hook and write a document that's too difficult to read. But, well, I'll argue both sides of that. On the side of being willing to make it difficult to read, that's largely because it's very terse, because things are not said more than one time, and because the consequences of statements aren't spelled out just the statements. And when you think about it, the way to avoid that would be essentially to put in a little bit more redundancy, to be willing to say things more than once. And if you're willing to do that, then there's a chance that you'll try to say the same thing twice and you'll actually say it a little bit differently the 2 times, in which case you've got an inconsistent standard. So there really is a danger there to be avoided. On the other hand, I think that we could avoid an inconsistent standard while also having something that was a little bit more readable. We probably should try harder in that respect.
Yeah, sorry that we could have more examples, and the advantage of examples is they are non-normative, meaning that they have no meaning in the legal sense. So they have no, they only work as an example, but you cannot derive from it how you should implement something or how the language works. And one should remember that in that sense the standard is like a law. There have to be no loopholes in there. It has to be very strict. There will be many times the words shall not, may not, must. Words you would not normally use in daily conversations. So that is why the standard is the way it is. And I even believe that because it's an ISO standard, that is actually a treaty between countries, right? So that means that it really is a law.
Yeah, we did need to get 60 votes in the US Senate to ratify it.
So I'm going to go back to that question about the technical versus non-technical composition of the committee. Typical meeting of WG21, as I say, is the working group we're all involved with, will typically be between somewhere between 40 and 70 delegates who are all technical specialists, coming from a variety of companies and a variety of national bodies. It's actually 2 meetings in one. We co-locate the ANSI meeting for the American C++ experts and the international ISO meeting, and we kind of hold the meeting under a joint jurisdiction, carefully shaking hands and making sure we don't contravene too much on either set of the rules. That committee can't actually make any normative, that's a working group, it's not a committee, so we can't actually make any binding decisions on ISO, but we send our recommendations up, we produce the standard document and all that wording, and it's the SC22 level, subcommittee 22, that actually does all the formal ISO voting and polling, and that is held at a separate convention, convention's probably not the right word, but meeting by Venus, I believe twice a year. That's where SC22 will have a delegate of each of its working groups, and that will say this is the work that's then proceeding at the international technical level. And I'm not sure if that again goes up from SC22 to the ISO level to get the ratification, and I'm fairly sure at the ISO level the technical understanding of C++ will be about nil. But they trust that all those people working at the lower subcommittees have done the right thing. They've got various polls that every time they think the document's ready for standardization, it goes through a process called an ISO ballot. It goes out for all the national bodies to read that document in a very technical way and submit any defects or issues they think they have before they'd be prepared to vote up and say yes. Otherwise, we now have the standard. When everyone, or enough people say yes, we get the standard. I think this time around, the first time it went out, we got about a few hundred comments. Second time out, it went again, got a few hundred comments, but that was enough that having resolved those comments, we could get the actual standard out fairly quickly. As for who is the audience of the document, primarily to an extent, it's the implementers of both the compiler and the libraries. But again, anyone who's using C++, if they're concerned, they think they've got a bug in their compiler, how do you know you have a bug in your compiler? Well, I look at the standard and say, does the compiler do what the standard said it has to do? Give me a very big hammer to hit my compiler vendor with. Now, if I'm not the sort of person who's using C++ at the level I'm exposing those bugs, what the standard says itself doesn't matter to me so much as those people who have built the tutorials out of the standard, those other book vendors. But again, it's setting the agenda. This is saying this is what C++ is, here's the contents of C++, and hopefully we can grow it in generations to come.
So I just want to make a quick little point on top of all of that. The standard says what is possible. It doesn't say what is wise. So it's better to have the books and tutorials written off of that to say, here's the mechanism and here's a good way to use it, the standard itself doesn't want to tell people how to write their programs. And so there's a gap missing there that needs to be filled in by somebody else.
I always thought the target audience was insomniacs. We got another quick question? Gabby?
Just to add to what Alisdair said. So the study committee basically had people from, MC, body, DSI. Alisdair is on both DSI and MC. But when we get to vote, it is a one country, one vote. So you get Switzerland, same vote as the US. I don't know how many times bigger. And yes, it is a treaty between countries. And I know that there are many instances when you get contract government, you require to use standards from the country. And if there is no standard there, you have to use the ISO equivalent. So usually you get the ISO standard, you get the ANSI C++. And what we usually do is that the ANSI guys get together and say, oh, there is no point in making our own C++, we're going to pretend that the ISO C++ is ANSI C++. It's the way it works also in France. In France, you cannot get any government contract if you don't have an African standard. And we don't make African C++, we just say ISO C++. And that's the way we actually operate for all the countries that are involved in C++. So it is not just showing people getting together having fun.
So I just wanted to add to what Gabby was saying about the way that voting works in the committee. So what he said is, of course, correct, that it's an international committee and therefore there is one vote per country. But there are two complications to that. The first is that, as Alisdair said, it's a joint meeting of the a committee of the US standards body, which used to be called ANSI and is now called something else, and the ISO committee. So the way things traditionally have tended to work is that when there is a formal vote, there are two votes, one for each of the committees. And some people liken it to the two houses of Congress. A motion passes if it gets majorities in both of the votes. But the second part is, I think everybody who's been on the committee knows this, the voting itself is largely a formal ratification more than anything else. It never happens that you have representatives of 7 countries and things pass on a 4-3 vote. If things are extremely close, then the officers of the committee will typically consider that to be a failure of process and something that deserves more discussion.
I'd like to add that, in my opinion, the last 2 years of this standard, and certainly the last year of the previous standard, was spent trying to make sure everybody were convinced that this was what they could get, this was the best they could do, this was the best they could get. If we just had voted something down, 2 to 1, we would have had a standard much earlier, but people would have departed from it instantly. And so there's a lot of consensus built into the process, and I don't think you could have a perfect set of voting rules for something as complicated and fluid as C++ standard.
May I ask a brief question? To follow up what Professor Stroustrup just said. So, if I understand correctly, we're not talking about a simple majority by any means. We're talking about 90% or more for consensus. Usually goes through Congress.
We like 90% of this.
But it's not that formal. No. It's the whole point is that there are formal voting rules. The formal voting rules are simple majority. In practice, that is not how it works.
Yeah, and there is another thing. In the moment we're voting in a committee on a real final draft of the standard that is going to be sent to ISO, then the countries get in the ballot to vote on that document. I believe that the ISO rules are like, there cannot be more than 2 votes against. So if 7 countries get to vote on that, if 2 countries say no, then it's almost gone. that means that already in the standards meeting, we will try to find out where the opinions of the countries lie, and if there are negative feelings, we try to get around those, instead of letting it come down to that 7-2 scary situation.
And just in case anyone's thinking that, hey, this sounds fun, I want to turn up for a committee meeting. We tend not to turn people away, and during the meeting, the actual evolution of how is it ever going to come up with these formal votes for how we're going to go at the end, there's taking many straw polls during the meetings, and during that process, everyone present in the room gets a vote. So a large part of the evolution is we're not down at the formal one vote per company, one vote per nation. That's when we get to the final, are we ready to go with this now? In the technical consultation, getting the paper to that level, yeah, we're very happy to bring people in. He says, running his recruiting banner.
Also, during the process where the actual work is done, it's not done by everybody sitting around in a single room. It's done in smaller working groups where the procedures are even less formal. There are typically at least 3 working groups going on at a meeting, and most of the time at a meeting is spent there, not everyone sitting in one room playing Minesweeper.
Okay, Gabby again?
So after this enthusiastic overview of the C++ process, what recommendations do you have for someone who would like to join the committee or at least present work and sees in an academic environment? What do you think would be a benefit for someone doing that kind of work?
Okay, I'll give a quick story of my very first meeting, which was the ASO meeting was actually being held in Oxford, which was about 10 miles down the road from where I was working. So I thought, I've got no excuse not to go to that one now. And I didn't know any better, I didn't know how to get involved. I wasn't involved in BSI at the time, but I was involved with the Boost community. And one of the secret agendas they don't advertise with Boost was it was also a recruiting drive to help to try to find people who would write and produce standard libraries to help produce the next standards. So knowing Beeman Dawes on the Boost list, he suggested that turning up to this meeting might be a good thing. And because I didn't know any better, I thought that I'm turning up to this meeting, I'd better write a proposal for show and tell. So I went away, and if you're wondering where the standard array class comes from in the C++11 standard, turning up to the first meeting, I thought I'd better write it the simplest thing I can find, so I have something to contribute. Turned out that wasn't necessary, but it was helpful that when we through the process, if you understand how does a proposal get written, and if you have something that you would like, a specific change you would like to make to the C++ standard, if you aren't prepared to sit down and write a proposal, it's probably not going to happen. If you want to effect a change, you sit down and you write a proposal. I would love to say that's enough, that's going to make a difference, but if you're not there at the meeting to champion the proposal, the committee don't know where to go for feedback. We can review it and say this is what happened, but it's much better to be there in person. That said, if you know you can't attend in person, if you know someone on the committee or can find a champion on the committee, we're always happy to try and help with these papers forward. If we go back again to when I first turned up, we were working on something that was called Standard Library Technical Report 1, a series of library extensions, and by far, I think the largest authors of papers and contributors of libraries to that proposal, Peter Dimov and I'm forgetting the name of the guy who typewrites Regex, John Maddock. So yeah, John Maddock and Peter Dimov. Neither of them ever turned up for a meeting, but they have a very significant contribution to that paper, so it's distinctly possible. But yes, if you're interested, I would distinctly recommend you write a paper, especially if you know someone like Bjarne, Gabby, who can help with the authoring and therefore champion your paper when they turn up. Go from the left on.
Yeah. You want to go first?
I was going to comment that the committee has never seen a paper it doesn't think it can improve. So if you do come with your cherry proposal, be prepared for having it, taken apart word by word in some cases, put together again. Also, I'd say you're going to become the standard body proposal. I mean, start something small. There's nothing that wouldn't come back saying let's rewrite overload a resolution from the beginning. You know, you're not going to get a very good reception of that, as I would say. But I mean, we're always looking for people to come and join us. You know, you don't have to be, you know, fully, you have to be like Alisdair, the first day with a paper. You know, it's okay to come for a couple of meetings and just sort of work out how the process moves along. But we definitely would love to have more people.
Yeah, writing papers is not a prerequisite to being very helpful and productive on the committee, because a lot of the work simply involves keeping an eye on what's going on, connecting the dots between different papers, critiquing what people are doing, you know, just providing good feedback to the people that are doing the papers. But if you decide you do want to do a proposal, I think the key thing to remember is you have to come in with a problem. If you come in with a feature, it's not very convincing. You come in with a problem that needs a solution. And you can present that solution, the solution you have, and even the syntax you have. But you got to be kind of flexible, because the solution you had might not be the one that the committee chooses. And it's almost certain that the syntax you come in with is not going to be the one the committee adopts. So you've got to be a little flexible there.
Yeah, and about new proposals, you should realize that there is a time in the development of a new standard where new things can be added, and there is a time where we have, well, sort of a feature freeze, where we only repair the damage that we have introduced by adding new features, and of course repairing the comments that we get from the national bodies. So those are two different kind of phases. You should not expect to get a new proposal in a year before the standard has to come out.
Yeah, and I think I would just add to that as with any software development organization, a very large fraction of what we do is not new features, but bug fixes. That's and the amount of time we devote to feature development versus bug fixes varies from meeting to meeting, but work on bugs is always a big part of it.
You want to come back to that, Bjarne?
First, I've just mentioned something. Very often, we get a proposal, or some of us get email, and it's basically the structure. Look at this neat feature. Just some code or something. People describe what they think is a neat idea, and the committee is supposed to guess why it's there, what problem it solves, all the technical details about how to implement it, what it cost, and such. I think a weakness in those proposals, a weakness actually in the way the committee operates, is that we're not putting emphasis enough on the rationale and the design. What is the problem being solved that was mentioned? What is specific to this solution? What alternative solutions are we deciding against, trying not to solve the whole problem? One of the problems with the committee is that they make everything complete. So there's many little sub-programming languages embedded around a new feature. And so there's not enough discussion about rationale and cost and alternatives. So too much thought about implementation, too little about rationale and direction. It's very hard not to have that bias.
That's one of the characteristic weaknesses of proposals that come in. Another characteristic weakness is proposals that aren't really proposals but just wishes. There are a lot of people who have written in saying, I would like to see a GUI library. Well, that's nice. I would too. There are lots of things I wish for, but that's not a proposal. And I think a lot of people don't realize it isn't.
Yes, I wanted to add to that new proposals should not increase the complexity of the language, or at least not too much, and it should keep it teachable. We should not create something in the language that is impossible to learn.
With a very patient hand over here on the right.
Okay, I have a question actually in the way it was left this. So we as students oftentimes have to analyze programs in C++, and because the standard is essentially like 1500 pages long, it's not always clear, and we don't always read the standard properly. So do you think somebody was talking today about the automated testing? Do you think you as a standard committee, if you produce the standard minimum, in some sense of minimum test cases for all of your issues, will it help the standard? Will it help, people? I mean, I'm sure it will help students like us because we have a ready test suite. But and I know like there are some test suites that are not coming from the standard. But do you think it should be a job of the standard to produce these minimum test cases for each of the issues you discussed, and whether that will help the standard?
Okay, so if I understand the issue or the question correctly, would it be helpful for if the standard committee were to produce a standard test suite for C++ that could then be read by the users? To an extent, we do have standard test suites out there. The trouble is they're sold by commercial vendors who gain a value from writing standardized tools to say we will certify your C++ standard. There's a money to be made in having standardization certification for ISO standards. But because those are commercial products, naturally it means that we don't have those separately published by ISO. But in general, I think that ISO doesn't do publication of the test suites and the certification processes. They keep the standard, and then they're happy for other people to endorse and ratify those standards. Would it be helpful to have such a thing? Possibly. I don't know what it would look like, but it would be so much larger than the standard itself. My general experience is that test suites are at least 10 times larger than the code they're testing if they're doing a good job. And if you're trying to distill a standard from something that big in that many special corner cases, yes, you might find that the test case you're looking for your specific case is there, but I'm not sure that you would find it if it was lost in the body of the whole. Anybody else want to take a question before I hand over to Bjarne?
In the old days, government financed standard activities, especially languages like Ada, and they did produce test suites. That's a very expensive operation, and it has been found that these test suites are not the same as testing the quality of the compiler. So there have been many well-tested, certified compilers that actually use this for real work. So what we have done in the C++ community, out of necessity, we don't have any resources, so we couldn't possibly buy a test suite. You can't have a test suite built and maintained by a bunch of amateurs. It is very, very boring and tedious work. And so instead, there are two companies that make a good living out of producing quality test suites that all the compiler vendors and some of the major users actually use. So we have a mechanism for doing this. It's the only mechanism we can afford.
And I would add that in addition to those two standard test suites, most compiler vendors will have, in addition, their own extensive set of test suites based on specific bug reports they've dealt with to make sure those bugs again don't occur.
Another issue, if you have ever worked in a compiler development organization, then you have undoubtedly licensed one of the commercial test suites, and you have almost certainly discovered something, that some of those tests fail and you think that they should not have because you think that the test suite vendor misinterpreted the standard. And so this is, in a sense, if the standards committee published its own test suite and said this is just as official as the written text, we would be in the same position as, again, saying the same thing twice, once in text, once in a test. And I guarantee you that in at least some cases we would get it wrong and we would be saying different things in one way than in the other.
Can I go back to the question? The Do I remember correctly you said that it would be easier to read the code, the test suite, or the test code than to read the standard itself?
No. I mean, if you write a tool that needs to then work at some point on the scale of the whole language, before we actually roll it out to the point, it would be nice to have a suite where we can run it for small examples and make sure we got the semantic points right.
Okay, yeah, then I will further remarks.
You'll notice in the standard there are quite a number of examples. We probably could do a better job of making those examples compilable. Most of them currently are just notional. There's no way that we can directly compile them. But again, when we make it compilable, we're putting more bulk into the standard. We're making the actual information density lower. So it's not clear whether that's the right trade-off to make.
The combinatorics of a C++ test suite is huge. I've been sort of doing some major work in our compiler the last couple of weeks, and to make sure I hadn't broken anything, I ran the code through one of the external vendors' test suites. It passed every test. I felt really pleased. So I ran it through one of our internal suites. It failed almost every test, and I was actually stunned that we have tests for stuff that the test suite doesn't have, and I really missed something. So having, I suspect if the standard added a set of tests, validation tests, I don't think that unless we had somebody who's willing to spend an awful lot of time, that we do more than sort of scratch the surface of the language. Because my experience is never the one feature by itself that causes the problem. It's when you combine features together that you turn up the really strange corner cases. Is there another question? I'll go. Yeah.
I have a lighter question. So, is there a particular, what's the silliest thing you remember being proposed to be added as a feature or a library feature?
Oh.
And the second part of the question was, same question, such that the feature of the library ended up in the standard.
I'll go because there's a feature I turned up with almost on the spur of the moment on a weekend. It went in that meeting. We've got a feature in the C++11 standard called nested exception. The idea is that if you're throwing an exception and you want to translate it into another type, but you don't want to lose the original exception, you want to somehow propagate both. So we've got a mechanism in there that allows you to catch whatever exception is currently being thrown in, and you obtain a pointer type called exception putter, and you can then throw this new exception type that will be the original type you wanted to throw, but you will also multiply inherit from this other tag type, so that once you've caught your original exception type, you can then rethrow it and catch it as the tag type if it has that, and then pull out the original exception again. This whole thing came up because people were talking about, informally within the BSI meeting, about trying to change the standard exception class so that the standard exception hierarchy could all do this kind of stuff by putting the facility into our base class, which seemed to be a poor design to be huge inflation of a specific class and then a requirement that all exceptions must come from this class. But I was very disturbed that the random names I happened to have while sketching the paper out a week before the meeting are the same names you will find in the standard today.
Well, I would say that the silliest thing in the standard is the fact that we have a limerick there. Sorry? It's gone. No, it's not gone.
No,
It's still there. It's still there. And we have the output of a game in the standard. If you look very well, you will find somewhere the word Studebaker and vivisectionist very close together. Yeah.
Well, there is of course a whole tradition of April Fool's proposals, and it's really hard to say which one is the silliest, but I think that my favorite still has to be Bjarne's overloaded white space.
Well, then there was a Sumerian numbers.
Yeah, that was a April 1st proposal, and I wrote that paper up, and it basically pays 60 numbers, and, using cuneiform number system, and somebody in the blogosphere picked up on it, gave it rave reviews.
That's probably my favourite keyword proposal I came up with, which didn't make it into the standard, but at one time when we were trying to figure out how to do thread-state atomic variables, or do we repurpose volatile, there's a huge resistance to adding new keywords to the language. So my proposal was we just recycle the phrase, do not break while using this. For some reason it didn't fly.
Yeah, I was curious about what language addition, your addition to the standard has been the most difficult, that stands out in your mind, let's say, over the last 10 years, just to put in because of its complexity, or what it's going to affect, and the most often that you put in because of all the things it might affect, if anything stands out.
So which feature do we think was the most difficult to put in? You mean that made it in, or that we considered?
Technically, not politically, but just so hard to put in. You wanted it, and it's just difficult to put in because of the things it affects.
I think you'll have a general consensus that the hardest feature we tried to fit in within C++ 11 was a feature called concept, which we tried to validate on the types of the template type parameters, or the values of the non-type parameters. That for a while was in the standard, but the more we started trying to use it in the library, the more we were just pushing down, squashing the losses that are coming out the molehills, and it wasn't going to fit within the time scale that's available. And I know there's still an awful lot of active interest in that we've got at least two people here, Bjarne and I keep forgetting your name every time I try to mention it. Malcolm? Yeah. And probably a few others around the room as well. We're very interested in making sure that the concepts feature doesn't go away. But certainly that was one of the larger technical hurdles we've had. Looking the other way, what do I think has been maybe caused the most problem through standardization of what has made it into the language? And I would say probably the R-value references were the least understood and caused the most surprising knock-on effects all the way through the standardization process, even from the author of the proposal, who's been fairly clear on the way through, but we've been learning that the interactions were such that we were continually revising our ideas about this, and didn't make too many changes to the language as a consequence, but a few late-breaking changes, even then, as we refined and understood what the consequences of this feature were going to be.
Yeah, I would go along with R-value references for the highest ratio of surprise and confusion to seeming simplicity of the feature. This one just turned out to be a lot more far-reaching than expected. But aside from that surprise factor, if I'm just going for what feature actually took the most amount of just hard work by a lot of different people to put all the pieces together, I would go for multi-threading. That affected many, many different aspects of the language and the library, and a lot of people had to pull together on that. And then if I'm talking about the C++ standardization process as a whole, as the first standard as opposed to C++ 11, I'd probably go for templates as the language feature that took the most work from the committee as a whole. That was a couple of years of solid work, at least.
Well, and then there are things that keep popping up that are in the standard that are in our way. And can I say vector of bool?
No.
I see the reaction.
That's just a word.
There are words, yeah.
Yeah, there are lots of words. Every project has them.
But vector bool, it survived at least 3 separate attempts of mine to kill it.
Yeah, two's a bird.
So I think one of the things that is difficult in the standard is overloading. So it took quite a bit of time over many cycles to settle on an algorithm that now doesn't change very much, which is why I was previously mentioned that you probably don't want to touch it because it takes a long time to stabilize.
Yeah, so Bjarne Stroustrup, not having sat in the core group and gone through all the defects reports, the overload resolution, took a large number and a long bug tail, but I think it's now pretty settled. At the moment, we still see a lot of issues with templates. Unfortunately, the current spike, so I say, of issues is coming from constant expert which seems to have grown way beyond what the original intention was, and hence it is. Hence there's a.
Paul was warned
Yeah.
by the proposers, don't go there.
They did listen, and it's an example of, just, I think now and again the committee, I wish somebody needs to stand up and tell people, just because you can doesn't mean you should.
Well, I do that every week.
Yeah. So, is there another? But yep, we're here.
With the introduction of the study groups going forward, do you guys see that really changing the way the standards committee works with that much asynchronous, or is this just formalizing what's been happening in between meetings via email and phone calls?
I think I'll say on a couple of levels there. Yes, I think it is just a more formalization, but also, I think what is going to really help is for these bigger proposals. The hope is by having these study groups, that means that when the final proposal comes to the committee, it'll be in a much better form. It'll be much closer to being finished. Now, it doesn't mean we still won't take the paper apart and put it together again, but we hope we'll get something that's much more complete first time. I'm actually not on any of the study groups, but Lawrence's he might have more to say.
So, back in sometime around 2000, there was work on a performance technical report. And one of the aspects of the study groups is that allows us to have a formal way to produce a technical report. And so some study groups are likely to produce a technical report. It won't be part of the official standard, but it'll get out, get implemented, get used, and then we can take actual field experience with that feature before we bring it back into the standard. And so that extra layer of formality permits us to do that.
I'll say I think one of the most successful experiments during the C++11 evolution was the library TR1. All the libraries that went through the process of going into TR1 were much higher quality of specification when it came to integrating them into C++11, even as some of the existing standard libraries that had already been written. The downside we had from TR1 was once that was done and we started focusing on C++11 was we didn't really get many new libraries after that point. That seemed to be the bulk. That document was done, and we didn't have time to kick off a second TR and get that through, and we didn't have a mechanism for getting other features through. The hope is that with these new study groups, we'll have a lighter weight mechanism to hopefully get more technical report-like documents through over the scale of the next standard. So we'll have, again, a variety of high-quality libraries and possibly some of the language features coming out of the network, not network, and the concurrency proposals. So we hopefully have a much more stable and rounded C++17 when we come around to that next standard.
The subtext to a lot of this is, for the most part, the committee does not want a much larger core language. The core language is mostly fine. There are a few things we want, but we don't think that a C++ with twice as many keywords would be a better C++. But on the other side, as Herb Sutter pointed out, Herb is the convener of the committee. He works at Microsoft. I'm sorry that he wasn't able to be here. But as Herb pointed out, if you look at some of the other popular languages, like Java, like C#, their standard libraries are immensely huge compared to C++. We're talking something like an order of magnitude. And, I'm sorry.
Or 2 orders.
Not 2 orders of magnitude, but maybe more than 1 order of magnitude. Huge. And a lot of people, including her, including me, think that C++ suffers by having too small a standard library. We think that it would be a better language if we had, say, 5 times as many things in the standard library. And a lot of us have wish lists for what we would like to be in that 5x. The study groups are in part an experiment to see how we can work more rapidly, how we can get a much larger library than using the processes that we've been using in the past.
At this point, after it's 5 o'clock, so technically we're done, but after this point, we're done for the evening and heading on for dinner later on. So I'm happy to keep going as long as the audience is interested to keep asking questions. I'll just check if that's true for the rest of my panel. Okay, so we're here as long as you want us. Next question.
This time around, why do you think the compiler writers have been so much more on the ball in giving the standard than they were before?
Okay, so the question is, this time around it seems like the compiler vendors are a bit more on the ball and getting compilers ready to ship than they were on the last standard. So why do we think that is the case if we agree that is the case? So I'm going to pass along to somebody who might be a compiler vendor on the left-hand side, and we'll work our way down the line.
Speaking from experience, it's just a matter of lucky timing. This time around, when the 98 standard came out, I got sucked into the .NET CLR world, and that was our focus for up to about 2003. I think we did a release in 2003 because we were so embarrassed by the lack of support of C++ 98. We actually did a whole release just focused on C conformance, but it really, from my perspective, from Microsoft's perspective, how much effort, we don't have the resources people think we have, but we've probably got way fewer resources working on the compiler than most people imagine. So it really depends what the management want, and I have to work hard to make sure that their goals align with my goals, which are definitely to add all the C++11 features. At the moment, we do appear to be working in the same direction, but that can change.
So one of the things that happened with the 98 standard is the difference between the language as it was before the 98 standard and the 98 standard is probably larger than the switch from C++ 98 to C++ 11. And in particular, the simpler the language, the simpler the structure of the compiler can be. And so at Sun, when we shifted to implementing the 98 standard, the amount of infrastructure that had to change in the compiler to make it possible to do the 98 standard was significant. And it appears to require far less of that for the 11 standard. So it's not that there's fewer features or less important features, it's just that they seem to torque the implementation less.
So I'm not a compiler vendor, I'm a compiler user, and I say my perspective hasn't really been that the compilers as a whole are that much more ready, but we do have a broader range of compilers that seem to be ready out the gate. GCC has done a very good job. They're close to complete, I think, on C++ 11, and Clang is similarly close. In terms of standard libraries, the standard libraries are in a much better position. Microsoft, I believe, will be shipping a full standard library with the next release. The GCC library is fairly close. There's a few corners it's not quite there on, and I'm fairly sure the Clang library is again similarly complete. So you've got three very good solutions there that are close to complete. As you look to the broader set of compilers that are out there that might be out in use, so Sun, IBM, and some of the other ones, well, they're still waiting. This affects me personally, is that I can't move my code at work until at least we've got 3, 4, 5 standard compilers we're using, and I need to move at the pace of the slowest one of those. So that could be a longer wait. If you're able to use a smaller range of compilers and able to stay with the cutting edge, there's certainly some compilers seem very keen to use C++ 11 as a competitive advantage, and I hope that idea grows.
Yes, and I don't really know if it's true that the adoption now is that much. You asked the question. If the adoption is better now than it was in '98. I had the idea I could do quite a lot of STL already just before '98. So, and it's indeed true that in '98 we got templates there, which was a big thing at that time, and now we're going further in templates. It's more of the same. There are some revolutionary things like argiving references that can have quite some complications, I think, in the compiler itself now. I'm not a compiler by the way.
There are complications there, but the question you have to reorganize the compiler's data structures. And we've had less of that.
Yeah, just to add to Lawrence's point, there was a story that I remember from the late 90s. There was one compiler team that started running into serious problems with their linker because their linker had a hard limit of, I think, 256 characters per symbol. And they had to make some major changes to accommodate the way that C++ was being used as a consequence of the standard. I don't know of any major changes like that that are required this time around.
So what's the biggest wish that you had for the 11th standard or maybe the next standard?
Concepts.
I'm going to irritate Bjarne with this one. Bjarne and I have a little history here. The single language feature I signed up for when I came to the C++ committee was I wanted to have keywords to control overriding virtual functions. I wanted to know if I was overriding my function correctly or not and have the compiler give me warnings and errors about this. And this feature was in and out and right on the cusp of whether or not it was going to make it into the standard all the way up to the end. And Bjarne wisely was just trying to steer me away from doing this, and I pushed on down. No, it was just going to come in. I just missed it, and then a comment came in on the national body comments that it was going to come back. And right at the last arc, it was in, and then they went and changed the rules of how it works slightly for me. So now it doesn't do what I want it to do. I should have listened to Bjarne and waited to have a chance to do it right.
So, I could probably talk for a couple hours on things that weren't there or were there, but probably the one that strikes me most is the ability to separate digits in a number with an underscore. It seems like such a simple, helpful feature, but we just couldn't get it in. So.
You don't want 5 specs? You don't want the 5-spec version?
No.
How about 5 specs version?
I'm not sure about the last standard, but for the next standard, I mean, I really, I still think the core of that language needs time to sort of quieten down after the release, so I don't want anybody to jump in and start, adding in major features, especially one thing about compiler vendors is you see C++ from the other side, that the people add features to that language and don't always think about what it's going to cost some poor compiler developer somewhere trying to get their compiler to work with this. And I think, as I work on a rather, what's the nice word to use here? Elderly code base, it's not always the most flexible. So I think I wish the next compiler is that my hair doesn't turn any whiter. I actually have brown hair when I joined at Microsoft. After 6 months of working on the compiler, I was white.
I think you get a little wish. I don't think you can get more.
And I will add a rejoinder feature the other way. The feature I didn't know I wanted until I had it, and I'll thank Bjarne for this one, which is the consistent initialization syntax in C++ 11. I'm not sure if this will be a love it or hate it feature, but intellectually I said that sounds like a good thing, but I just couldn't see myself writing curly braces everywhere. And within 5 minutes of having this syntax, I never want to go back. It's a real pain to go back to a C++ 3 compiler at work and have to go back to all the variety of initialization syntaxes. The little things seem to be the ones that can make the biggest difference just in the field of your daily use of the language. Anyone else? Do you have another question?
I think my two biggest wishes are first a single technique for handling Unicode that just works instead of 3 or 4 that mostly work, and second, enough library support that I can write a useful HTML server in 20 lines.